But like one day, somebody stole one hen. Couldn't tell that much, right? There's a 10 hen going around, so you didn't know. But next day, another hen is gone. Oh, start to wonder. Looks like something wrong, right? So I need to do something, right? So, but still don't know how to count, right? So they got stone. They match each of those, right? Now, next day, in order to steal one hen, they need to steal this stone too, right? So, but they keep this stone in their under their, pillow, right? So now, from next day, they can tell if there's any hen goal, then they can tell, right? But this is like kind of some development, right? Some progress. But there's a lot of hen. You cannot do it that way. So they start to think, there's any other way? Yes. Especially, like we need a stone. No. So they started to it using this symbol. This is Chinese 1, 2, 3. And even Roman, like that, right? But they could do 1, 4 like that, and 5 like that, right? Oh, sometimes you know this, right? That's why you can do it, because otherwise there's so many things you need to write it out, right? So they might start some way they do it. But now they kind of develop, okay, there's my easier way. Now anywhere, even North Korea, okay, they use this, right? And then you can keep on going, right? The symbol, they start to use it. What do you call this number 1, 2, 3, 4, 5, 6? What do you call that?
Base 10.
Oh yeah, that's a digit, right? Yes, that's one of the very important invention, the digit. But for now, let's say 1, 2, 3, 4. Those number, what do you call it? What number is that?
The Arabic counting system?
Yeah, this is Arabic, right? Good. But we call those number counting number. Understand? 1, 2, 3, those are counting number, right? Counting number. But official name of the counting number, you can call it still counting number. We call it natural number. Natural number, because we see in the nature. So we call it natural number. Everybody got it? And those natural number set, we use N. Okay, capital N stands for natural number. Everybody clear? So those natural number is 1, 2, 3, because in the nature, there's no 1.5 hen, right? So natural number is 1, 2, 3, 4, 5, 6. Those are we call it natural number, right? But let's say here, 2 apple, okay? But Andy and Alex and Abby, each of them 1 apple, right? So they start to, okay, let's catch 1 apple each. So got each, but now this time Andy couldn't get any. So Andy says that, oh, not fair, let's do it again. And put it back, and they did it one more time. This time, Abby couldn't get any. So they do it again and again, still there's a solution? No, there's no solution, right? So, but before do that, okay, there's a 2 apple, right? And Andy, and Abby ate 1 each. So there's a 2 apple right there. They eat 1 each. How many apple left? How many apple there? No apple, right? No apple. In order to express no apple, they start to think, how can I express that? So they invented 0, right? 0 is one of the very important invention. Okay, 0 apple, no apple is 0 apple, right? So even just one number 0 and all those natural number together, we have a different name. What do we call it? Anybody know? We call whole number. And then you can write it W, whole number. Okay? 0 and any natural number together, we call it whole number. Everybody got it? If I say whole number, then you think that's 0 and all natural number. That's whole number. Everybody clear? And then, so, there's 2 apples, there are 3 people. So there's no way all of 3 people can have each 1 apple, right? So what happened? So
They
yes.
split them.
Oh, that's another solution. But before that, they start to think, okay, so there's a 4 apple and 3 person, they can get each, 1 apple left, right? 1 apple left, they can write it like that. But now, 1 apple short, right? 3 people, 2 apple. Then 1 apple short, right? So, in order to distinguish that 1 apple left, 1 apple short, we start to write it. Let's write 1 apple short like this. Everybody got it? So that's negative number there. Negative 1, negative 2, negative 3 right there. So all those, we call it is positive integer. And 0 and negative integer. That one we call it integer. Integer is negative 0 and 1, 2, 3, 4, 5. That's natural number, but still that's positive integer. And then negative 1, negative 2, negative 3, that's negative integer. Everybody got it? All together we call it integer. But integer we write it z. You can think this way, 0. Okay? Integer symbol is a z. Everybody clear? And good job right there. Want to be fair, only 2 apple, right? We know that 1 apple short, so, but still only 2 apple. We got only 2 apples. So we want to be fair. Then what we can do? Cut it in 3 pieces each, right? And then they get how many pieces they can get each, right? Each person can get 2/3, right? Oh, this number, for example, let's say this 1 apple, they cut it into 3 pieces, 1 each, we call it what? This is what? 1/3, right? So this is you cut 1 whole thing, cut it 3 pieces, and then 1 each. To express that, this number is what we call it now. 1/3, what we call it? 1/3 is what? This is fraction, right? Oh, this is a fraction? Yes, this is what we call it fraction, right? Fraction is, you can write it numerator and denominator, right? That's fraction. Everybody clear? But any number you can write it a over b form, we call it rational number. And then rational number you use q, okay? You can say quotient, division, right? And so 2 is rational number. 2 is a rational number. Rational number is you should express a over b form. Yes, because you can think as denominator is 1. Everybody clear? So all natural number, all integer, you can express as a over b form, right? Which is, that's a rational number. Everybody clear? You can think as denominator is 1. But when you tell the what belong to what set, you need to simplify first, you need to answer. Okay? So anything 4 over 2 is a fraction? No, you can simplify 2 over 1, which is 2, right? So this is natural number. Everybody got it? Natural number, but still that's a whole number. That's an integer. That's a rational number. Everybody clear? Okay, so 1 over 3, they try to express this one as, right? But that one, can write it what? This symbol, you know that, right? So this one, we call it what now? Decimal, right? So you guys learn, like changing from the fraction to decimal to fraction, you need to do the long division, right? And then practice that. Especially from this, we call it this repeating decimal, right? From here to go to the fraction, you guys practice it, right? You might do it later. So, that means decimal, we call it, there's a finite decimal. Finite decimal is 0.5 like that, right? And that means there's an infinite decimal. Infinitesimal, like this is infinity, right? Keep on going. This one we call it repeating infinitesimal. That means there are non-repeating decimal too, right? So one of those typical one is pi. Pi is what? You say 3.14? 3.14 is wrong. Because that's approximation. In order to do a convenience, we use 3.14 as a approximation. But if I give you homework, write it out. Pi, whole value, impossible. You just keep on going. And then no pattern. You cannot express that way at all. Okay? So, non-repeating decimal, you cannot write it out. So only way you can do it, you borrow the symbol. So they borrow pi. That's a symbol. And then you guys know this numbers? We call it radical. Any sign of root, square root, and then cube root and fourth root, right? And so 5, like that. Everybody clear? Yeah. So all those so that means those one you cannot change to A over B form. Irrational number you cannot change A over B form. So only way you can express this one as a symbol. Clear? Yes. And then all rational, irrational together, we call it real number. Everybody got that? Okay.